Okay, so in this video we want to look at 3D vectors and how to do arithmetic with them. So let's take a look at arithmetic. Arithmetic of three-dimensional vectors. Okay? And so the good news is it's the same as with 2D vectors. So scalar multiplication, and vector addition or subtraction, work just as in 2D. Okay? So we can try some examples of this. Let's do that. So for these examples, let's suppose that vector v equals 2, -3, 4, and the vector u equals, how about 4i minus 5k. So I've made a point here to write one vector using component form and angle brackets, and the other vector in component form using the unit vectors I and k. Note that there's no j component here, so that just means you have a 0 middle component. So for the first example, let's, in fact, you know what, let's do scalar multiplication with vector addition and subtraction in one example, and we'll call this video good, because there's nothing really new here. So let's calculate -5v plus 3u, all right? -5v plus 3u. So we have scalar multiplication by vector v, scalar multiplication by a vector u. Each of those will result in a vector, a 3D vector, and then we'll add those two vectors together. So writing this out, it looks like this. We've got -5 times vector v, 2, -3, 4, plus 3 times vector u. And just for the sake of consistency, I'll write vector u in component form as well. So that'll be 4, 0, -5. And then we'll do just order of operations, we'll do the scalar multiplication first. So this turns into -10, +15, -20. When we multiply each of the components by -5, that's scalar multiplication. Plus, let's multiply each of these components by 3. So 12, 0, -15. And the last thing we need to do is vector addition, because we're adding two vectors now. So we add the vectors by adding the corresponding components. So -10 plus 12 is 2. 15 plus 0 is 15. And -20 plus -15 is -35. And that's what you get when you take -5v plus 3u. So that's a mix of scalar multiplication with vector addition. If we had vector subtraction, you'd do the same thing. Multiply this vector by the scalar 3, but then you would subtract the vectors. Okay, so no big deal there. That's a quick brush up on arithmetic of 3D vectors.